Hi students, so we will continue on with the osmoregulation part here. Okay, so osmoregulation, when you break up the word, osmo means water, regulation means you regulate the quantity of the water that enters back into the blood plasma. Okay, because we are made up of about 70 to 80% water, so the quantity of water in the body system have to be kept at a rather regulated level itself. Now, that's where homeostasis comes in. Okay, so as you saw earlier on, homeostasis is a negative feedback system. So basically, it corrects whatever that is deviating from the norm. So for example, if the person is on a very hot day, is losing more water, then of course you can't release out too much water into the urinary tract itself. Okay, so all this is controlled by this hormone called the antidiuretic hormone. Now, the antidiuretic hormone doesn't just stay around in the blood plasma freely being released at all times. The release or the lack of release of ADH is actually controlled by the brain. So it's a multi-step purpose whereby any changes in the osmolarity of the body system, or rather the concentration of water in the blood, is being detected by a specific part of the brain called the hypothalamus. Okay, so the hypothalamus will then determine or detect the amount of water concentration in the body system and correctly inform another gland, which is called the pituitary gland. Okay, now pituitary gland is the one that contains the ADH, and pituitary gland will then decide whether it has to release the ADH or it has to stop the release of ADH. And this set of instructions for whether to increase the release or to stop the release, the set of instructions is given by the hypothalamus of the brain. Okay, so when we look at here, what happens? We will just look at over here. So this is your negative feedback system. Okay, so let's say for example, when we look at the one on the left, when you have got water potential that is rising in the blood plasma, so which means a person is drinking more, or it is an extremely cold day and you don't have much water loss to the environment through the water vapor that you breathe out or through the sweat that you are giving out. So the water potential in the blood plasma increases. So this sends a stimulus, which means it sends a signal to the brain, the hypothalamus specifically. Now, the hypothalamus will then tell the pituitary gland. So in this case, because the hypothalamus is signaling the pituitary gland now acts as the effector. Okay, so the pituitary gland receives the signal from the hypothalamus, lesser ADH is released. Okay, so since prior to this information, there is already ADH in the blood system acting on the kidneys, it can't possibly just reuptake back into the system. However, what it can do is that the pituitary gland can release lesser ADH or absolutely stop the production of ADH temporarily. And from there itself, the kidney tubules will reabsorb lesser water. Okay, so kidney tubules will then undergo vasoconstriction, so meaning to say that it constricts a little bit in size. Okay, so when it constricts, it is not able to take up as much water. So when that happens, the more water will be released out as urine. The urine looks more diluted. The water potential in the blood plasma now goes back to normal, and it will just be status quo. Okay, now if the reverse is to happen, so for example on an extremely hot day, or the person has not drank sufficient amount of water, so again same thing, a drop in the blood plasma will be stimulated to the hypothalamus. Okay, so the stimulus will act on the receptors of the hypothalamus. The receptors will then inform the effector. In this case, the pituitary gland will release more ADH hormone into the blood plasma. So ADH will be carried throughout the blood plasma itself, and then it will bind onto the receptors of the kidney tubules. Okay, so instead of vasoconstriction, now it will undergo vasal relaxation. Okay, so when it relaxes, or you can say vasodilation. Okay, so when it dilates, what happens? More water gets reabsorbed back into the blood plasma. So now I don't have so much water going out as urine. I have got more concentrated urine, which looks yellow, more yellow in color. So more water being reabsorbed into the blood plasma. Now my blood plasma water potential goes back to normal. Okay, so you can see that whenever there is something that deviates from the norm, be it increasing or decreasing, a whole set of processes will be released out in homeostasis to correct it back. Okay, so now that's the part for osmoregulation by ADH. Last but not least, we will look at a component on the dialysis machine, which is a pretty short component.